Assalamu alaikum. We are here for the 43rd lecture in software requirements engineering. In the last lecture, we talked about web-based information systems and what are the issues in requirements engineering for those types of models. Today, we are going to have another very interesting area that needs to be looked into as far as the requirements engineering is concerned. And that area is product lines. What we will do today is that we will see what product lines are, and then we will look at some of the issues in requirements engineering as we did in the previous discussion. So, what are product lines, and how did we develop interest in product lines? The interest in software product lines emerged from the field of software reuse when developers realized that they could obtain much greater reuse benefits by reusing software architectures instead of reusing individual software components, that is, code only. And that realization over the years resulted in the development of a separate area of interest, area of research in software engineering, and that area now is known as product lines. Product lines architectures, product lines, we will be only talking about product lines as it relates to the requirements engineering activities. But product lines are a very important emerging area in which there is potential for software, for research in software engineering. So, but I have mentioned another thing, and that is software reuse. Before we go into details of product lines, let's take up this topic of what software reuse is and how, what kinds of software reuse have been going on for the last several years. So software reuse has been a goal in software industry, in software engineering communities since 1968. And so this is not a short period of time. We have been looking at trying to achieve software reuse for quite some time now. The goal for software reuse is to maximize productivity, minimize cost of development, and to improve the productivity and to improve the profits for the software vendors. These are all very high aiming goals, and research has shown that software reuse can significantly contribute to the achievement of these goals. And research has been continuously being done in software, in different sub areas of software reuse, so that we can achieve these goals. Software reuse initially was only limited to code reuse, and that too in use of mathematical libraries. And that has been a remarkable success in the computing industry in the last 30-40 years, that use and reuse of mathematical libraries have achieved all of these goals. That is, they have increased the productivity, they have reduced the development costs, and improved the profit situation for the people or the companies who are developing software. And so the naturally next step was to go for design reuse, and there have been a lot of efforts in that area also. And then requirements reuse, knowledge reuse have been the goals in front of the software community, and in particular to people who are interested in and are actively conducting research in the area of software reuse. Software reuse has been a proper specialized area of research, and there are a number of internationally recognized conferences held on a regular basis which focus on this area. And for the last several years now, product line development or development using the product line approaches have been included in these conferences, and many groups participate and present their results to the industry, to their peers, so that they can get their feedback, and all a comprehensive research base can be developed, an asset base can be developed that can benefit the software industry as a whole, but particularly those organizations which are interested in applying software reuse to achieve the goals that I had mentioned earlier in the lecture today. There was a very famous researcher and teacher in our industry. His name was Parnas. He referred to a collection of systems that share common characteristics as a family of systems. Now, this is something that sort of goes beyond one system, one application. What he's talking about here is a collection of systems that is sort of a family of systems that share common characteristics. Now, the Parnas's point of view was that it is worth considering the development of a family of systems when there is more to be gained by analyzing the systems collectively rather than separately. That is, more features in common than features that distinguish them. And this is a very interesting thing. This is a very interesting point of view in which, when the vendors are looking at the requirements for an application, they, instead of looking for requirements for one application, they look for requirements of related applications also, and in that they develop a knowledge base, a repository sort of, for a family of systems, a family which has many characteristics which are common among individual members of that family. And that was the thesis, and that has been validated by use in the industry. Now, if we carefully analyze this situation, if we carefully look at the thesis that Parnas had put before us, this is the beginning of what is known as software product lines now. A software product line consists of a family of software systems that have some common functionalities and some variable functionality. Now, the idea is that if individual system belongs to a family, then it must have certain things common with other members of the family, and it may have, in fact, its own very unique characteristics which are not universally shared among all members of that family. Some of those characteristics may be shared by others, and it may have some characteristics which are not shared by any other member of that family. Now, to take advantage of the common functionality, reusable assets are developed. And this is how we take benefit from developing an asset base of those things, those features, those components, those relationships, those interfaces that exist between the systems that can be reused by other members also. And so since our goal is to apply those techniques which fall under the software reuse paradigm, and as a result, as you can see, that if we can analyze a family of systems and use those artifacts, use those elements in the development of individual systems, then we do not need to analyze the individual systems again and again, and we can develop reusable asset base. These assets include, that is, the reusable assets include requirements, they include design, they include components, and they include other things, design decisions. Sometimes rationale is stored as an asset, and interfaces can also be stored as assets. These assets can be reused by different members of a family. As I have just said, that once an artifact or once an asset becomes part of the repository, then that asset can be applied, can be used by other members of the same family, and the more it is used, we have the better chance of achieving the goals that we had stated earlier, which is primarily to increase the productivity and to minimize the cost of software development. The software industry is increasingly recognizing the strategic importance of software product lines. Product lines are not new, and they have been used in ancient era also. If you think about a very important style of buildings, and you have seen pictures or you may have visited those areas where certain buildings are developed in the same way, although they have different sizes and they have slightly different individual features of their own, but their overall construction philosophy, construction design is the same. If you think about it for 1 second, I'm sure you'll be able to guess that I'm talking about the Egyptian pyramids, where the basic shape of a pyramid is the same. The differences are in the size, in the color, maybe individual unique characteristic of each pyramid, which separates an individual pyramid from other pyramids of the same family of pyramids. Now, think about what I had said just a few minutes ago about software product lines, and if we compare our pyramids with that definition, we can easily say that one pyramid belongs to a family of pyramids. We can also say it in other ways that we have a product line of pyramids in Egypt. And so this concept of product lines is not new. Now, if we look at the modern era, we also see product lines everywhere. In fact, in this era, product lines can be found in practically every domain, in every area, in every business. I would pick up the most beautiful example of the European Airbus, where they have A318, A319, A320, A320 airplanes, which share common product features, including jet engines, navigation equipment, and communication equipment. They also vary, that is, each model varies from other models in different ways. Maybe their seating capacity is different, maybe the power of the engines is different, maybe they have a different fuel carrying capacities, maybe their cargo carrying capacities are different. The individual appointments in each of these models may be different, but fundamentally they are all Airbus products, and they share the same family of things. And now recently we had this A380, which is again a kind of an Airbus, but it's a very different kind of Airbus. It's a double-decker situation where you have two floors, two decks on an aircraft. And so even that aircraft shares some features, some characteristics with these single-deck aircraft. And so you can find the same thing in computers. You can find that in laptops there are multiple series that a laptop maker issues, and fundamentally they have common features, but individual model varies from the previous model or the newer model. And this is because the companies have realized that this is where the economic benefit is going to be the profit making is going to be if they provide the customers with variety of similar products for the customer to choose from, depending upon the amount of money the customer is willing to pay. And so in the modern business marketplace, it is important that software industry should also adopt these practices and start developing products which conform to this overall business philosophy of product lines. The traditional mode of software development is to develop single systems, that is, to develop each system individually. For software product lines, the development approach is broadened to consider a family of software systems. And as I was saying, that it makes a lot of business sense to go after this product line software development approach, because it enables the vendor to perform a comprehensive analysis of the requirements and of the characteristics that can be included in the software products, similar but different software products, and the possibility of selling those software products to different customers increases significantly, and the possibility of having or developing a large customer base certainly is going to have a good impact on the financial situation of the company which is developing software in this way. A software product line is also referred to as a software product family, a family of systems, as I've said before when I was talking about the Parnassus ideas, and an application domain. This is also known as an application domain. The terms used most in the early days of this field were domain analysis and domain engineering. And you would continue to see these terminologies used in the literature today, particularly the domain analysis term, because that is a term which clearly resonates with the requirements engineering is concerned, and as far as requirements engineering is concerned. And we have talked about looking at the application domain when we were talking about requirements elicitation and requirements analysis, and we talked about domain requirements as a separate subject during the earlier lectures in this course. And the architecture developed for application domains were referred to as domain-specific software architectures, because they were architectures which applied to a particular application domain, and they were relevant only in that domain. In the specific application domains, but since we are not going to talk about in detail on architectures or domain-specific architectures, we'll focus only on the requirements engineering side. So this approach, that is the approach of product line development, involves analyzing what features of the software family are common, what features are optional, and what features are alternatives. And when I say features, I mean requirements here. You can say that a requirement can be a single requirement, can be a group of requirements. And so I'm using this in general terms, and especially I can say that a feature refers to as a functional requirements, although there is no harm in considering features to consist of non-functional requirements as well. And so you can loosely say a feature is equal to a requirement, and I'd like to keep that at that level of ambiguity. Now, after the feature analysis, the goal is to design a software architecture for the product line which has common components. These components are required by all members of the family. So these are common components. Architecture also consists of optional components which are required by only some members of the family, and variant components, that is, different versions of which are required by different members of the family. That is, the variant components can either be common components or they can be optional components, but they may have, whenever a component is categorized as a variant, it can have one of possible versions or specialized components of either a common component or an optional component. Now, to model and design families of systems, the analysis and design of family of systems, the analysis and design concepts of single product systems need to be extended to support product lines. All this means is that if you are going to develop product lines, you are going to enhance, extend the concepts that you have used for analysis and design of single systems to include a family of systems, so that a large number of applications or individual systems can be included in that family. Now, you do not have to necessarily include systems which artificially, that is, they do not belong to the family, but if you should try your best so that you do not leave out certain members of the family which may be more variant or which may vary more as compared to the rest of the family. Now, as I said, that is the product line development or software product lines have been an area which is attracting a lot of attention by researchers. We need to define or provide some commonly understood definition of what a product line is. So we can say a set of software-intensive systems sharing a common, managed set of features that satisfy the specific needs of a particular market segment or mission, and that are developed from a common set of core assets in a prescribed way. That can be a definition of a product line, and this is provided by Clements and Northrop, and these are two very famous authors, and their work was done at the Software Engineering Institute. And so one thing that this definition does not specifically include is the concept of managing variability in software product lines, and that I had earlier referred to as the two key things. One is the management of the common features or common characteristics, and other is the management of variability. And in my view, both of these combined must be included in the development of software product lines. Modeling commonalities and variabilities is a very important activity, and there have been a number of product line techniques that I will mention shortly, but there is something that I would like to talk about, that is the importance of variability. You see, things that are common among all members of the family are easily modeled, because these are the fundamentals or things that don't change between individual members of the family, and these are the core assets that both Clements and Northrop are talking about. What I think is very important is the fact that individual members of the family have their unique characteristics and unique features which must be fully documented within the product line information model, along with the common features and common characteristics. If we don't do that, we will have only a partial information, and we will not be able to completely take advantage of or benefit from the product line development. And so whenever we are working on the product lines, it is very important to model both the commonalities and the variabilities of the product lines. And it is, in my view, commonalities, you have to do that because that is something which makes it a family. Otherwise, there'll not be a family of systems. But variability is also equally important, and there needs to be not only techniques to manage variability, but also to document and to put them in repository so that whenever individual systems are being developed or being tailored or individual application engineering is being done, then those varying aspects, those variable features, those variable characteristics are then brought along with the common features or common characteristics. Now let's look at these techniques that I mentioned. These are some of the early product line approaches, and I'll talk about them just in a passing reference, and then we'll take up some other issues related to the product lines. Number one is the family-oriented abstraction, specification, and translation. That is FAST technique. Then there was a lot of work done at Software Engineering Institute. Then there was work done at Software Productivity Consortium. And lastly, it's the Evolutionary Development Life Cycle Model. You can call it EDLC. And I had my humble contributions to the development of the architectural sides of the Evolutionary Development Life Cycle Model. And since we are not going to talk about the architectural aspects of the product lines, only the requirements engineering side, so I'll leave my own contributions to the software industry or software body of knowledge to some other day. But these were the early product line approaches that were reported in the literature. As I have mentioned, that the variability in software product lines can be modeled at software requirements level and also at the design level. The most widely used approach for modeling variability in requirements is through feature modeling. And as I have just said before, that we can almost compare a feature to a requirement. And now this is really a very vague equivalence, because a feature can be one requirement, a feature can be 100 requirements. So depending on how you group the requirements together to equate to a feature. But generally we can say that when we say features, we mean high-level requirements or requirements in general. Features are an important concept in software product lines because they represent reusable requirements or characteristics of a product line. That's what I was saying. And then the concept of feature is quite intuitive and applies to all product lines, not just software product lines. So as I was referring to you, mentioning that Egyptian pyramids are like product lines, and in the modern business environment so many product lines, and I mentioned only the Airbus product lines, but you look around, and I also mentioned probably laptops. You can look around and see that almost in every business you would see product lines being made available to their consumers. And so software is not the only example. Now, one example that I would like to bring to your attention is the product lines of our vehicles, our cars. Every car manufacturer has a product line available for their customers to choose from. Every product has some common features in it. These are the features that are available in all the models of a particular vendors or particular car manufacturers' products. Then there are alternative features, those features which one can get instead of some other features. For example, you can have a seat belt or you can have an airbag. That's an option. Thirdly, there are optional features, things that you may or may not want. For example, you may not want a sunroof for your car. That's an optional feature. It doesn't bother how your car operates or how fast it runs or how comfortable it is, but some people want to have a sunroof in their cars, and so that's an option. And there are so many other optional appointments, as they say, are available in the automotive industry. And so this is an example that we deal with on a regular basis, and so software are also like that. The concepts that I've talked about, that is the features, are the most common ways of modeling commonality as well as variability in at the requirements level. And since variability is the aspect of product lines which distinguish individual systems from other systems, so therefore it is important to focus only on features which manage or which document variability. There is a very interesting, the work done at SCI includes FODA, which is a feature-oriented domain analysis method. The FODA approach uses features which are organized into a feature tree. Features may be mandatory, they may be optional, or mutually exclusive. So there are three kinds of features: mandatory, optional, or mutually exclusive. Other product line methods also used features, and the one that I worked on, the EDLC model, also used features as for modeling variability in product lines. What are common features? Common features are those features that must be provided by every member of the software product line. That is, these features must be available in all members of the family of systems. They are also referred to as mandatory, necessary, or kernel features. Features which must be there in every member of the family of system or every member of the product line. And then there are optional features. Optional features are those features that need to be provided only by some members of the product line. Now you can clearly distinguish that the common features are those features which are required by every member of the product or every member of the product line or every member of the family. And optional features are those features that are needed by only some members of the product line. Optional features can assume that common features are provided, and so they can depend on the presence of the common features. So this is where the individual characteristics, the unique requirements or unique attributes of individual systems in a family start to distinguish themselves from other members of the family. Then there are alternative features. Two or more features may be alternatives to each other, where only one of them can be provided in any given member of the software product line. Thus, in this case, the features are mutually exclusive. And so we can have a feature set where only one member of the set is allowed to be included in an individual member of the family. Now, with this, we can see that there is interesting distinguishing factors being added using a combination of features. I have used a new term here, feature set, which probably should have raised some alarms in your brain that we had not heard this term before. By feature set, I mean that we can group features and we can call them feature groups. So related features can be grouped into feature groups which place a constraint on how the features are used by a given member of the software product line. And so by taking this approach, we can even increase the possibilities of combinations of these feature groups. So let's discuss some feature groups that can be applied to when we are analyzing the family of systems. The first one is mutually exclusive features. A feature can be an alternative, which we have seen that if you have two features and one of them can be included in a system, then these are alternative features. A feature that is included in a set of features and the condition imposed it is that only in some product families, only one of the alternatives may be always allowed to be included in a product line, in a product family member, then that feature set becomes a mutually exclusive feature set or a mutually exclusive feature group. There is no limit on the number of features included in that set. In other cases, however, selecting one of the alternatives is optional for a given member. So there are two possibilities. One is that you always will include a feature from this set, and the other is that you may not include a feature from this feature set. And a 0 or 1 off feature group handles the case in which selecting one of the alternatives is optional. And we'll see that group in a little while also. So when we say mutually exclusive features, we mean that we have a set, a list of features that can be included in a member of the product, software product family, and we must have at least one of those features, and not more than one can be included in any member of the family. Now the next feature group is exactly one of feature. Exactly one of features. In this group, a feature must always be selected from the group. Unlike the mutually exclusive case, the option of not selecting a feature does not exist. This group is also known as one and only one of feature group. It is possible for such a feature group to have a default feature and to have a prerequisite. The feature group must contain at least two features, one of which could be a default feature. Now, we require at least two features because we must include one feature in every system of the family. And if there is only one member of the set, then it does not make any sense to have a set like this. The third kind of group is the at least one of feature group. In an at least one of feature group, one or more optional features can be selected from the group, but at least one feature must be selected. That is, you can select more than one, but you must at least select one. It is also possible for this feature group to have a default feature and to have a prerequisite. Prerequisite means that this feature requires another feature to be included. The feature group, that is the at least one of feature group, must contain at least two features, one of which could be default feature. Again, the rationale for this I have just explained while I was talking about previous feature group. Now there is another interesting feature group, that is 0 or more of features. At first, a 0 or more of feature group might seem unnecessary, since 0 or more means that all features in the group are optional and there are no constraints on feature selection from within the group. However, sometimes it is useful to group optional features together because of some dependencies. For example, all features in the group depend on another feature or feature group, and sort of you are combining features out of necessity, out of concerns, out of constraints that are dictated by the management of the features rather than their domain dependency on each other, rather than their own relationship with each other. And so it is that kind of feature set which have minimal bonding with each other, but they belong to the set because of some dependencies on some other feature sets. And there is usually no default feature in this case, because the name, as it says, is that you are not required to include feature from this sort of set. Now, this is the basic modeling of features or feature sets or feature groups in the analysis of requirements for product lines. Now, what happens if the number of requirements increase tremendously, as they will in product lines? When we are considering software product lines, the number of requirements will increase substantially, because we are not only dealing with one system, but we are dealing with a large number of systems who belong to one family. What should you do in that case? The idea is then that you should have advanced feature groups. You should provide combinations of features as one feature, and then you need to develop relationships between those feature sets or advanced feature groups, which will then make your organization of features easy. Initially, we were talking about features as equivalent to high-level requirements. Now, when we talk about advanced feature groups, we can think of advanced feature group as consisting of several features. And so the management of these features become manageable and easy as compared to the situation, when we are going to eventually deal with a large number of requirements in family of systems. Now, let's talk about a little bit on different requirements engineering aspects of product lines. First, that is very important, is that the requirements engineering for product lines is going to be a more comprehensive and more laborious and more difficult task as compared to individual systems. This is a fact, because the effort that is required to analyze a family of systems is going to be substantially higher or substantially more complex as compared to the analysis of one system. One of the things that we talked about when we were discussing requirements engineering aspects of web-based information systems, we also said that the front-loaded activities in the web-based information systems is very high, and so is the case in the development of software product lines. The requirements engineering activities of software product lines are going to be very complex. They require a great deal of domain knowledge. they require a great deal of analysis and negotiation, prioritization, and documentation, that is correct specification. They also require comprehensive validation. Now, the difference between development of product lines and with the web-based information systems is that in the web-based information system, the delivery cycle is short. But if you're working on the product lines, it is not expected that you will be having a shorter delivery cycle because of the nature of product lines. You are not going to be delivering software products if you're using product lines approach in shorter cycles. You need to have a comprehensive requirements engineering activities. You need to have a comprehensive domain analysis performed. You need to classify and cluster the information that you have gathered in that domain analysis, and your requirements elicitation has to be very organized, and you must meet different types of stakeholders in order for you to capture the domain knowledge, which is so very important, because now you are focused not only on one thing, but you are focused on a family of systems. You are going to develop knowledge base, a domain knowledge for a large number of systems which are included in the family. And so when you are working on the product lines, it is very important to have a thorough and complete requirements engineering process. You need to spend time on it. You need to categorize the non-functional requirements. You need to categorize the functional requirements. You need to identify the domain requirements, and you need to organize your requirement sets in 3 possible ways: common requirements or common features, optional features, and then alternatives. Today, I've talked to you about and discussed with you different aspects of software product lines and the importance of requirements engineering activities in product lines development. And in the next lecture, we'll take up another interesting topic. Till then, I take leave of you. Allah Hafiz.